Next example, solve x cube plus xy raised to 4 dx plus 2y cube dy is equal to 0. So this is the given differential equation. Compare with m dx plus n dy is equal to 0. We get m as this and n as this 2y cube. And then dA by m by dA by y means derivative with respect to y. X cube derivative is 0. And x constant, derivative of y raised to 4 is 4y cube. So we have 4xy cube. And dA by n by dA by x, 2y cube derivative is 0. So dA by m by dA by y is not equal to dA by n by dA by x. So the given differential equation is not exact, but we observe that dA by m by dA by y minus dA by n by dA by x divided by n is 4xy cube, this is dA by m by dA by y, minus 0 divided by this n is 2y cube. And so we have the answer 2x is the function of x alone. And so by using the rule, we have the integrating factor is e raised to integration fx dx. That is e raised to integration 2x dx. And this is integration 2x dx. And what is the integration of x? It's x square by 2. So 2 to get cancelled. And so we have e raised to x square as the integrating factor. So this is the example which is not exact, but it is reducible to the exact. And it is the example on the rule number 3. The rule number 3 and 4. What are the rule number 3 and 4? These are the rule number 3 is dA by m by dA by y. The given differential equation is not exact, but dA by m by dA by y minus dA by n by dA by x divided by n is function of x alone. Then e raised to integration fx dx is the integrating factor. Is the function of x alone or is constant quantity. So we have here the value of this quantity in our example that we have the 2x as the function of x alone. Or you put dA by n by dA by x, that is this dA by n by dA by x right first, then dA by m by dA by y second, and divided by m in place of that divided by n, there is e divided by m, and is function of y alone. Then integrating factor is e raised to integration f(y) dy. So all these questions are important for MCQ type questions. That is, if this is equal to a function of x alone, then integrating factor is this. So these rules are important for examples, MCQ type examples. So this is the example now. Solve this. Okay, so what is the MCQ type question on this example? That is, this is the given differential equation, and the question is which of the following is integrating factor of this differential equation. So we have to find integrating factor, and we have that dA by m by dA by y minus dA by n by dA by x divided by n. That is, we apply to obtain the integrating factor. There are 6 rules. One is by instruction method. The second is what? The 5 rules. These 5 rules. So in order to find integrating factor, in all there are 6 rules or 6 methods. These 5 rules, and the first method is what? These tricks, that is use the instruction method. That is, by using instruction method, by using these tricks, we can obtain the integrating factor. For example, if the equation is instruction method, when we use the instruction method, when the equation is y dx minus x dy is equal to 0, so apply the y dx minus x dy divided by y square or divided by x square is the integrating factor. So 1 by y square or 1 by x square is the integrating factor, and x dy minus y dx, then 1 by x square plus y square is also integrating factor. So it depends on the example. So for this example, y dx minus x dy, the integrating factor is 1 by x into y, 1 by y square, 1 by x square. So this suggests by using this integrating factor is obtained by using observation, by using instruction method, that is, and by using these tricks. So there is term y dx minus x dy, then the integrating factor may be 1 by y square, 1 by x square. So this is the gauge. By using this gauge, we can find the integrating factor. So y dx minus x dy, then 1 by x into y is also integrating factor, 1 by x into y, and x dy plus y dx. So what is the integrating factor? 1 is the integrating factor, because this differential equation is the exact differential equation. What is the m? M is x, and if you take the differential equation, x dy plus y dx is equal to 0, then what is the integrating factor? Integrating factor is 1. So y dx x dy. So what is m? M is x and n is y. So dA by m by dA by y is 0, dA by n by dA by x is 0. DA by n by dA by x is 0. So if the equation is x dy plus y dx is equal to 0, then 1 is the integrating factor. So remember that if the given differential equation is exact differential equation, then its integrating factor is 1. That is, if dA by m by dA by y is equal to dA by n by dA by x, then the integrating factor is 1. So how we can find integrating factor? We can find integrating factor by using these tricks. This is the first method. Then find the integrating factor by using these 5 rules. Now, rule number 1, rule number 2, rule number 3, rule number 4, and rule number 5. So there are all the questions of the integrating factor of MCQ type are solved by using these 6 methods. That is the first method, this method, and these 5 rules. So if the question is which of the following is integrating factor, then we have to apply the all we have to check whether one of the method out of these 6 method is applicable, which of the method is applicable. So it's depend on you. For example, this is the example, that is, and we are given this example, this as the given differential equation, and suppose the question is which of the following is integrating factor. So this answer is given, e raised to x square answer is given in the multiple choice questions. So out of that 4 choices, we have to find the correct answer. So how we can find the integrating factor of this differential equation? We have to apply one of the method out of that 6 methods, and we have to decide which method is applicable to this. So it is by using trial and error method. We cannot suppose that we have directly this answer, that 1 by e raised to x square as the final answer. So we have to find we have to apply the first method, second method, third method, rule number 1, rule number 2, rule number 3, rule number 4, rule number 5. If the rule 5 fails, all the rule 5 fails for the example, then apply the inspection method. And remember that if the given, suppose that we have dA by m by dA by y is equal to dA by n by dA by x for the given differential equation, and the question is which of the following is integrating factor, then answer is 1. If the given differential equation is exact differential equation, for example, this example, suppose this is the given example. This is the given example, x square minus ay dx minus ax minus y square dy is equal to 0. And suppose the question is which of the integrating factor of this differential equation, then answer is 1. Integrating factor is 1 because we have dA by m by dA by y is equal to dA by n by dA by x for this example. And so 1 is the integrating factor. So if the given differential equation is exact differential equation, then 1 is its integrating factor. So if suppose the multiple choice question is this, that given that m dx plus n dy is equal to 0 is a exact differential equation, then which of the following is integrating factor? Then the answer is 1. If the given differential equation, either it is a general differential equation m dx plus n dy is equal to 0, suppose, or suppose this is the differential equation, given differential equation, and the question is what is its integrating factor, then write 1 is its integrating factor. So the given differential equation is exact differential equation, then 1 is the integrating factor. But the given differential equation is not exact differential equation, then how we can find its integrating factor? So there are 6 methods. So I apply one by one. Apply first the 5 rules. So first find dA by m by dA by y, dA by n by dA by x, and if these two are not equal, then we have to find the integrating factor by using one of the method out of the 6 methods. So this is the method that if dA by m by dA by y minus dA by n by dA by x divided by n is function of x alone, then e raised to integration fx is its integrating factor. If dA by n by dA by x minus dA by m by dA by y divided by capital M is function of y alone, then e raised to integration F.Y dy is its integrating factor. So remember one rule out of these 2 rules, that dA by m by dA by y minus dA by n by dA by x divided by n is function of x alone. And what is its parallel rule? Next, rule number 4, that is replace this, write this dA by n by dA by x first, then dA by m by dA by y divided by m is function of y alone, then e raised to integration F.Y dy is its integrating factor. So there are MCQ type questions on this integrating factor, and now we have to solve this differential equation. So multiplying by integrating factor, that is e raised to x square throughout to equation 1, we have this e raised to x square x cube plus x y raised to 4 dx plus 2 e raised to x square into y cube dy, right? Y cube here, y cube is missing, right? Y into y cube, 2x e raised to x square into y cube dy is equal to 0. So write that y cube here, which is exact differential equation though. So after multiplication of integrating factor, the given equation reduced to the exact differential equation. So this is the exact differential equation, and this is m, and this is n, and then its general solution is integration m dx plus terms in n independent of x dy is equal to constant c1 as constant c or c1, and then you write m as this dx, write first formula, that integration m dx plus integration terms in n independent of x dy is equal to constant, and then there is this term 2 e raised to x square into y cube. This term is depend on x, so here is 0. Only one term in n, and that term is depend on x, and therefore 0 dy is equal to c1. And so we have to integrate this. So simplify e raised to x square x cube dx plus e raised to x square into x y raised to 4 dx. So right here plus sign, it is not equal to plus sign, right here plus sign, e raised to x square x y raised to 4, and y raised to 4 is constant quantity, so take out of the outside the integration y raised to 4. So e raised to x square into x dx is equal to constant, right here plus sign, and then substitute x square is equal to 2 for this integration. Substitute x square is equal to t, and so twice x dx is dt, means x dx is dt by 2. So we have e raised to t, and this factorize this x cube as x square into x, and that x square is t, and x into dx is 1 by 2 dt. So we have 1 by 2 integration t e raised to t dt 1 by 2 dt, take 1 by 2 as constant, so outside the integration. So substitute x square as x equal to 2, and this is the integration by using part rule. This is the integration by using, okay, it is again x square, so directly substitute x square as t, and so x dx is 1 by 2 dt. So take 1 by 2 as common outside the integration, so it is constant, so take outside the integration. So we have e raised to t, x dx is 1/2 dt, take outside 1/2, so dt is there is equal to c1, and so integration by parts rule, this integration. So first is t and e raised to t is second. So first integration of second e raised to t, integration is e raised to t, minus integration of second e raised to t, integration e raised to t, derivative of first t, derivative of t is 1 dt, okay, plus 1/2 y raised to 4 is constant, e raised to t integration is itself e raised to t is equal to c1, and then e raised to t integration is e raised to t. So we have this, and then substitute e raised to t multiplying throughout by 2, and write this 2c1 as a new constant c in the next step, and then substitute this t as x square. So take t e raised to t common, we have t minus 1 in bracket, so x square minus 1 e raised to x square, right? Substitute e raised to x t as x square, then y raised to 4 e raised to x square is equal to 2c1, and this 2c1 as c, this is the general solution. Okay, by taking e raised to x square as common, we have x square minus plus y raised to 4 minus 1 e raised to x square is equal to c, well 2c1 as c, and which is the general solution of the given differential equation. So this is the example of the type rule number 3. If fx is a function of x only or x alone is an integrating factor of the differential equation this, then find the form of fx and hence solve the equation. So we have to find, we are given that fx is the integrating factor of this differential equation. So, and we have to find the value of fx, and then we have to solve the given differential equation. So the given differential equation is this. So multiplying this fx to given equation number 1. So what do we have? We have this differential equation. After multiplication fx, we have this differential equation, and obviously this is now this is exact differential equation, because Fx is the integrating factor, and so after multiplication of integrating factor, any differential equation reduced to the exact differential equation. So these become exact differential equation, and in which this is m and this is n. So compare with this m dx plus m dy, we have this m, this is n, and then dab by m by dab y. Now we have to find dab by m by dab y. That is the derivative with respect to y. So fx is now constant quantity, and derivative of x raised to 4 e raised to 4 is 0 minus 2 mx y square, derivative is 2y. So we have minus 4 mxy fx, and dab by n by dab x is with respect to x derivative. So 2my is constant quantity, and x square into fx derivative is by using u into v rule. X square f dash x plus derivative of fx as f dash x, derivative of v, plus 2x fx as it is, and derivative of x square is 2x fx. And since the second is the exact differential equation, because it is obtained from equation number 1 by multiplying fx as integrating factor, so this equation is exact, and so we are dab by m by dab y is equal to dab by n by dab x, and that is dab by m by dab y is this, dab by n by dab x is this, and so cancel the common factor of both sides, m and this 2 and all these factor, we have x f dash x plus 4 fx is equal to 0. By cancelling the common factors, that is cancel m, divide throughout both sides to 2, and then cancel x into y, take x common from these two, so cancel that x into y. So we have x f dash x plus after plus 2 into 2 is 4 x fx, x get cancelled, x take common, so x 4 fx is equal to 0. So after simplification we have this, that is cancel the common factors of both sides, and then we have f dash x divided by, shift this term to RHS, and so f dash x divided by fx is minus 4 by x. So shift this to RHS, it will become minus 4, then shift fx to LHS, then shift x to RHS. So f dash x divided by fx is minus 4 by x. So integrating both sides. So this is by using rule, integration f dash x divided by fx is log fx. It is a standard rule. Integration of f dash x divided by fx is what? Is log fx, is equal to minus 4 is constant, and integration of 1 by x is log x. So integrating both sides with respect to x, we get this. And log fx is then this minus 4 shift to x raised to minus 4, because we know that m log a is log a raised to m. So it is log x raised to minus 4 means log 1 by x raised to 4. X raised to minus 4 means 1 by x raised to 4. Cancel log of both sides. So fx is x raised to minus 4. Fx is x raised to minus 4, that is 1 by x raised to 4. And so this is the integrating factor. And then multiplying this equation by 1 by x raised to 4. So we get this differential equation after multiplication by 1 by x raised to 4. And this differential equation is exact differential equation. So separately divide x raised to 4 to this, multiply 1 by x raised to 4 to this bracket. We have here x square, and x square get cancelled, 2my divided by x square. And this differential equation is exact differential equation. So its general solution is integration m dx plus terms in n independent of x dy is equal to 0. So this term is depend, there is only one term in n depend on x, so 0 dy, and write m as it is here. And then we have to integrate with respect to x. So e raised to x integration is e raised to x itself, and minus 2m y square is constant, and the integration of 1 by x cube. 1 by x cube means x raised to minus 3. So integration e raised to x dx, minus 2m y square is constant, and 1 by x cube means x raised to minus 3. And then e raised to x integration e raised to x minus 2m y square, and then integration of x raised to minus 3 is what? X raised to minus 3 plus 1 divided by minus 3 plus 1, that is integration x raised to n rule. By using that rule, we have x raised to n plus 1 divided by n plus 1, that is x raised to minus 3 plus 2 plus 1 divided by minus 3 plus 1. That is, we have x raised to minus 2 divided by minus 2 answer. That is 1 by x raised to minus 2 means 1 by x square. So minus 1 by 2 x square is the integration of x raised to minus 3 by using the rule x raised to n. And then we have this answer, that is minus minus become plus e raised to x, right, 2m, 2 to get cancelled, m y square by x square is equal to constant, or we can multiply throughout by x square. So we have this answer, which is the general solution of the given differential equation. So given that the integrating factor of this equation is of the form y raised to n. Now find n and solve the equation. Now we have to find the value of n. So y raised to n is the integrating factor. So this is the given differential equation multiplying by y raised to n to this given differential equation 1. So after multiplication of y raised to n, we have this. So y in raised to n into y is y raised to n plus 1. And here we have 3 y raised to n tan x minus this sec square y. This is sec square y divided by y square. So y raised to n divided by y square is y raised to n minus 2. Like by using the rule, x raised to m divided by x raised to n is x raised to m minus m. Division implies the subtraction. If the bases are same and if there is division, then we have x raised to m minus n. X y square y raised to n divided by y square is y raised to n minus 2. So x square y dy is equal to 0. And this is m, and this bracket is n. And now dab m by dab y with respect to y derivative, sec square x is constant quantity. And y raised to n plus 1 derivative is n plus 1, y raised to n plus 1 minus 1 means y raised to n. And dab n by dab x is, we have this tan x is now this 3y raised to n is constant, derivative of tan x is sec square x, and this total quantity is depend on y, so it is constant term, so its derivative with respect to x is 0. And obviously we observe that these two are not equal. These two are not equal. But when what is the this is the given differential equation. After multiplication of y raised to n, this equation becomes an exact differential equation, because y raised to n is integrating factor. This equation is second is integrated is an exact differential equation. Since the equation second is exact, and so what we have, dab m by dab y is equal to dab n by dab x, and substitute dab m by dab y as this value, dab n by dab x as this value. So comparing these two, that is, we have n plus 1 is equal to 3 by comparing that. Cancel y raised to n sec square x, y raised to n sec square x. We have n plus 1 is equal to 3. So n is equal to 2. So y square, now y square is the integrating factor of this differential equation. So multiplying this differential equation number 1 by y square. So what we have? We have this. After multiplication integrating factor to equation 1, we have this. And then which is an exact differential equation. So, and so its general solution is what? Integration m dx, that is y cube sec square x dx, plus terms in n independent of x, is this term is dependent on x in n. So this term minus x square y is independent of x term, right? Minus integration minus x square y dy is equal to constant. And then integration is with respect to x, dx means integration is with respect to x, y cube is constant. And what is the integration of sec square x? Is tan x, because derivative of tan x is sec square x, minus this minus sign, and integration of sec square y is tan y, because derivative of tan y is what? Sec square y with respect to y is equal to constant, and this is the general solution. So we know again the definition of integrating factor. Integrating factor is what? Is the factor by multiplying it to the given differential equation, it becomes exact differential equation. So the question is find integrating factor and solve the differential equation. So the given differential equation is this. So if you this is compared with the equation m dx plus n dy is equal to 0. So this is m, this is n, and if you find my means dab m by dab y. This is the PDF of another book. So here the notation for dab m by dab y is my, m suffix y, and dab n by dab x means dab n by dab x is denoted by nx. So if you find my means dab m by dab y with respect to y derivative is this, with respect to x derivative is this, and these two are not equal. Dab m by dab y is not equal to dab n by dab x, and therefore the given differential equation is not exact. But we have to solve the differential equation. We have to find integrating factor. So we have this dab m by dab y minus dab n by dab x divided by n is what? So dab m by dab y is this, dab n by dab x is this. So that subtraction becomes 6x cube y square into y. Here is not suffix y, my. It is not my. It is what? Dab m by dab y minus dab n by, yes, dab m by dab y is this 6x y square minus this 6x cube y cube minus this minus 6x square. So minus 6y square, 6xy square, and this Their subtraction 6xy square and minus 6xy square become 0. So we have actually minus 6x cube y square minus 8xy as the answer. Divided by n, divided by this. So minus sign is here. Divided by n, divided by n. N means this 3x square y square plus 4y. And then take uh, 2x common from numerator. So we have uh, in bracket 3x square y square plus 4y in bracket, and cancel that to denominator. We have the answer minus 2x, and which is independent of y, or this is the function of x alone, and therefore integrating factor is what? E raised to e raised to denote this is by fx, denote this minus 2x by fx is equal to fx, and then integrating factor is what? Integrating factor is e raised to integration fx dx. So this is an xerox of this is the PDF of another notebook. So here is the, instead of fx the notation is px, px denoted by minus 2x. And what is integration of px? Minus integration 2x dx, this minus sign, and this is minus x square, x square integration of 2x, 2x is what? 2 into x square by 2. So x square minus x square is the integration of this. And so integrating factor is what? Here is denoted by mu x, or we say just integrating factor I dot f dot is equal to e raised to integration fx dx. Integration of in this notation, integration px dx, that is minus x square. E raised to minus x square is the integrating factor, and then multiplying by e raised to minus x square to the given differential equation. This differential equation, we have this differential equation, and which is exact differential equation. This is the exact differential equation, and now its solution is what? Then multiplying by e raised to minus x square to each term, we have this dx. Then multiply this e raised to minus x square to both term, we have this dy is equal to 0. And now this is an exact differential equation, and so its solution is integration m dx plus integration terms in n independent of x dy is equal to constant. So integration 2 e raised to x, write m all these four terms dx plus integration terms in n independent of x. So there are two terms, this is the first term and this is second term, but this term contains x, this term contains x, and so there is no term independent of x in n. So write 0 dy is equal to constant, and so integration is 2y cube. So we split the integration. So integration of this first term, this integration is with respect to x. So this 2y cube is constant, integration e raised to x square x dx. Again the integration of this 2y cube is constant, minus 2y cube e raised to x square, integration e raised to minus x square x cube dx. Similarly simplification of this, minus 4y cube is constant quantity, and here we have plus 2 is constant quantity, e raised to minus x square x dx is equal to constant. And then substitute x square is equal to t. So twice x dx is dt, means x dx is 1/2 dt. X dx is 1/2 dt. So 2y cube e raised to minus x square e raised to minus t, and x dx is minus is 1/2 dt. Here is right 1/2 dt. Here is the wrong, right dt by 2 or 1/2 dt. So right here 1/2 because it is x dx. So x dx is 1/2 dt. So right here 1/2 dt. Or write this 2 in bracket and then 2x dx as dt. So right, cancel this 2 or write here 1/2. So extra right here 1/2 minus 2y cube, again e raised to minus t, and this factorize this x cube as x square into x dx, and write x square as t and x into dx, right 1/2 dt. Here right again 1/2 minus 4y cube, again here e raised to minus t 1/2 dt, right here 1/2, and again here 2 and e raised to minus x square x dx, again write x dx as 1/2 dt. So right here 1/2 1/2 1/2 1/2, and then cancel throughout that 1/2. Or write the next step as 2y cube e raised to minus t. So correction is one, right each in each term 1/2 dt, and then cancel 1/2. We have this, the cancel 1/2 throughout. So we have this, or then 1/2, take 1/2 as common. So 2 into 1/2 becomes here 1, here 1, here we have minus 2, here we have 1. So correction is there. I think final answer is correct, but here write just x dx as 1/2 dt. So then next step is uh, y cube. This one half get cancelled through this y cube, or take a, if you multiply by 2, then all this one half get cancelled, so we have the same step. Then 2y cube e raised to minus t, integration is e raised to minus t divided by minus 1. Again here by using part rule, so this t is first and this e raised to minus t is second, so use the part rule first, that is t, integration of second e raised to minus t, integration is e raised to minus t divided by minus 1, minus integration of second e raised to minus t, integration is e raised to minus t divided by minus 1 into derivative of first is 1 dt, minus 4y cube e raised to minus t, integration e raised to minus t divided by minus 1, again e raised to minus t, e raised to minus t divided by minus 1. And then simplification is this minus minus become plus, and e raised to minus t, integration is again e raised to minus t divided by minus 1. So the remaining quantity, then manage these constants, then we have this, that is substitute e raised to t as x square, t as x square, so substitute t as x square, and then this term get cancelled. After simplification we have this, dividing by 2 we have this answer, so this answer is correct now. So if you write 1 half dt as 1 half dt, 1 half dt, 1 half dt, and then we have the same answer, dividing by 2 we have this as c by 2 is new constant, suppose c1, so take e raised to minus x square as common, so x square y cube plus 2y square minus 1 is equal to c1, and this is, if we shift this e raised to minus x square to RHS, then it becomes c1 e raised to x square, and this is the general solution of the given differential equation. So all these examples are depend on the rule number 1, 2, 3, 4, 5, 5 rules of that integrating factor. The given differential equation is either exact or reducible to the exact. So we will see all the remaining problems, and these are the exercise on this topic. There are in all 15 to 20 examples for homework. Their answers are also given, so we have to solve all these examples. So we will see the remaining examples of this type in the next lecture. So this topic is important as far as the exam concerned. What is the type? This type is exact differential equation, and the differential equation reducible to the exact differential equation. And under the second type, reducible to the exact differential equation, there are 6 methods, sub methods to find integrating factor. So we will see the remaining examples in the next lecture.